Okay, this question comes from Hokut on the Gear Sluts audio forum. I/O electronics package and computer audio interface. Do you mean limited to connecting a stereo signal for the speakers? Or does the system come with some sort of multi-I/O audio interface that allows you to connect, say, 8 or 16 audio inputs to a computer and also function as a monitor controller for the S600s?
Okay, we designed the ADIO box to be, as best we could, a super clean interface that was without problem. And in other words, it was user-friendly, not user-vicious. So the first thing we did is to get the XMOS engine in there, which is capable, provided that the digital audio workstation is capable of it, to run 10 channels up to the DAW at 192.24 and 10 channels down from the digital audio workstation at 192.24 with under, I think it's 2 milliseconds, maybe 2.5 milliseconds, something around there, latency anywhere in the place. As a practical matter, the computer may very well say, well, I'm setting the USB incoming and outgoing rate to 48 kilohertz, 4816 or 4824. Whatever it says, that's what the front end of the system will sync to. So the idea is that, let's say that you used what we think is the most important part of the ADIO box, which is the two analog to digital converters combined with the incomparable ingenious input system. Okay, so let's say you were using those two things. We always clock that digital analog to digital converter at 192.24. So whatever analog you present to the ingenious system is going to be encoded at a very high bit rate and a good bit depth. And then maybe that will have to be asynchronous rate converted to match a low rate going up to the computer, or maybe the computer will allow 192.24 to go up, in which case that's how it arrives. Simultaneously, we can provide one digital stereo signal that is could be SPDIF, could be Toslink, and could be AES-EBU, and that too will be rate converted to whatever the computer wants, but it can come in at anything. The unit doesn't care. Of course, the best possible performance is that when a signal comes in at somewhere right around the rate, like in other words 192.24, and let's assume that the digital audio workstation is set to that rate, well then that's the cleanest going up. Finally, we've got an ADAT option which will allow for, I think it's called SMOD or SBUF, I forget which, that allows for varying bit rates with using an ADAT box, where 8 channels will come in at 48, 4 channels will come in at 96, 2 channels will come in at 192. All of those signals will be available simultaneously up at the digital audio workstation, and they have all been asynchronous rate converted to whatever the workstation wants. So for that reason, we're presenting a pretty clean signal going up. Coming down, again, you can get 10 signals that are 192.24, and we distribute them to, of course, to the monitor speakers, but also to headphone monitors that you might be using in a separate tracking room. And by the way, we have a talk switch on the apps that run the ADIO, and a talk circuit to run just run a cord out to the other room where you've got your tracking going on. And then also we have a couple of different options for headphone amps and so forth, which you probably even kludge a way to get a sidechain going, or in other words, get a compressor limiter in there that you're particularly fond of the sound of, or whatever. But again, the fact remains that the ADIO box was designed more for musicians and less for recording engineer producers, because pretty much every person who is recording, certainly for a living, or who is a very serious recording enthusiast, is going to have other ways around the stuff that the ADIO box does. Our point was to put it all in one place so that it kind of prevented you from making a mistake if you were just a musician who wanted to get their creation down for posterity.